Looks like we have. All right, perfect. We got our recording started. So we're going to start with our first student on our list. That's Naveed. For those of you who don't know who Naveed is, he's one of my students. He's been here since the first session. He has a super awesome project that I've really enjoyed talking to him about, especially since it's in my area of expertise. It's a very custom built project. So without further ado, Naveed, would you like to share what you built with us?
So I'm Naveed. I'm a rising sophomore at Saratoga High School, and I made a remote control robot that doesn't hit obstacles. So as you can see, the base project was an obstacle avoiding robot, which I then modified to make it remote controlled. I chose this project because I like RC cars, and making them not hit obstacles is pretty cool. I used an ultrasonic sensor which emits sound waves and determines the distance to an object based on how long it takes for the sound wave to come back. I also have a pivot on a servo, as you can see in the front of the robot. So the robot can detect any obstacle in front of it, even if it's really small. So the first modification I made was the custom controller, as you can see right here. This comprised of a 3D printed case, 2 potentiometers to control the steering and throttle of the robot, and an ESP32, which sends Bluetooth signals to the car. Along with the custom controller, I also made a new 3D printed chassis, as you can see here, which has steering similar to an actual car, where the original was more similar to a tank. As you can see, the front wheels can change direction, can spin in multiple directions, which allows it to turn. The hardest parts of the project were learning about all the different electrical components, debugging electrical issues, and making the custom car chassis. And my favorite part of the project was learning, was having the freedom to do whatever I wanted with it, and my instructor would support me. I learned a lot about the debugging process and how to design something in a way that would be strong, but also light at the same time. And I learned I like mechanical and electrical engineering, which I want to do more of in the future. Any questions?
Yeah. Do you want to talk a little bit more about like how you built that controller? Because it looked really cool, and I know kind of how that controller works, but I don't know if everyone else knows, and it's just something truly spectacular.
Okay, so what I have in the controller is, so I mentioned I use 2 potentiometers, and so one of them for throttle, I used, so the potentiometer, it basically, what it does, it allows you to, when you rotate it, it'll know that it's rotating. So you can kind of like, you can use that, I use the potentiometer, and the potentiometer will read a value, and that'll send it to the car to tell how fast it'll go. And I also have another thing, I use springs to make the potentiometer be able to kind of zero itself out. So when I release the potentiometer, it'll go back to the 0 position. So it'll automatically stop the car if I let go of it. And for steering, I just took the potentiometer and kind of tilted it 90 degrees. So now I can use that, and when I turn the potentiometer one way, the car will know to turn that way, and then when I turn it the other way, the car will turn it the other way. And so I mentioned the ESP32. It has an integrated Bluetooth module, which allows it to send signals to the car, and that's what I use so I don't have to have any wires from the controller to the car.
Awesome.
That's cool.
Great job. I love that project a lot. It was really cool watching it come together. So very excited with how it turned out. Shifa, would you like to introduce your next student?
Yeah, sure. Yeah. So next is Hadley. And yeah, before we start, I want to tell something about him. Like when I remember when it was his first day and he didn't know what all those components were delivered were, and he was very confused and how to get started. But now, as you'll see in his presentation, he's so confident about building circuits, and yeah, just see how he presents. So the floor is yours, Hadley. Go ahead.
All right, hello. My name is Hadley G.S. I'm a student at the Urban School of San Francisco. I graduated in 2022, so that means I'm a junior. And today I am presenting my robot arm. So I can share my screen here. All right, so the robot arm itself is, oh, wait, let's see if I can get that out of the way. There we go. The robot arm itself is controlled by 4 potentiometers, which each control a corresponding DC motor. You can sort of see, I guess you can see all 4 of them there on the arm itself. So we have the hand, elbow, shoulder, and base servos. And on the coding side of things, the project is run on Arduino, which is in this image, I guess, hidden behind the breadboard. But to function, the Arduino reads an input coming from the potentiometer between 0 and 1023 using the analog read function. And then once that value has been stored, the code scales that input down to a proportional value between 0 and 180 using a function called map, because the motor itself can only rotate between 0 and 180. Finally, the Arduino can send that value back to the motor, and thus the arm moves. So I can shown here. In fact, I think if I speed myself up here, you all can see this thing in action. Of course, this thing can move with different potentiometers at the same time, but I had another hand stabilizing the camera, so I can't show all the functions here. But there we go. Wow. Awesome. So one of the modifications I made, actually this modification was made today in the past 3 hours, but I connected an ultrasonic sensor to the Arduino. Let's see, here I'll rotate it. There she is, right there. She's the 2 cylinders connected. And what happens is I introduce code that reads the distance between the ultrasonic sensor and an object between.
I got different thing. You're not posted a white shirt.
It reads the distance between whatever is in front of it.
Just a breakout room or where the room it is.
And if the sensor reads
is a male
below 20 centimeters, the code will stop and force the hand open and drop the object. So let's see if I can, right there. And very cool. So with this project, one of the main challenges I had on the software side was with the motors, and therefore the arm was consistently jamming up when I ran my code. So with some more focused looking, I found in most cases the motors were jamming up only when I was rotating the potentiometers to their extremes, so approaching 0 and approaching 1000. And essentially what I found is that some of the motors, based on the build of the arm, do not allow that full turning radius of 0 to 180. So to fix this issue, on all but one motor, I restricted the rotation such that the code wasn't mapping from specifically 0 to 180, but rather 40 to 150 on the elbow motor, for example. The largest challenge I faced, though, was a twitching phenomenon, because, or for a while, as soon as the arm was hooked up to its power source, the entire project would twitch, so much so that I have videos in my camera of the thing twitching itself essentially off the table. So at first, I believe this was a lack of power issue, and I was working my way up from 6 volts, 7.5, and 9 volts, cutting wires, and I bought 20 battery packs or battery holders. But eventually, a little voice in my head said, "Wait, have you tried less power?" So I returned it back to the 5-volt native pin on the Arduino, which sends 5 volts of power, of course, and the twitching stopped. And bam, there we go. Now it's functioning. Lessons learned. It's corny, but it's often the smallest issues that are causing the hiccups and that are causing error, from like which pin you're on for PWM, non-PWM analog, or in that last challenge, of course, 1 extra volt of power. that have hung me up for the longest periods of time, days often. So maybe that's a valuable life lesson. It's the small things. And yeah, questions if there are any.
Yeah, any questions for Hadley? Parents, you wanna go? If you have any questions. Okay, I have a question.
So
Yeah, so I even didn't know you made a modification by the end of the day today. So how did you figure out what was your major motivation with that?
I felt as though my project was very, very simple and that there wasn't any variation in the code. It was kind of read the input, then send the input or map it, then send it to the ARM. So I wanted to create an if loop, which I had never tried before. So I did some research today on how to create an if loop, how to read an ultrasonic sensor. And also I just love circuitry challenges just because that was the thing that was grinding my gears for the first week and a half of Bluestamp. So it felt like I was proving myself.
Great, good work.
That was an awesome project. I
Yeah.
love seeing that. Next up, we had a couple mechanical projects, but this project is mostly software project. Up next, we have Rashonda. Rashonda came in like most of our Bluestamp students, not knowing a ton, not having a huge background. Yet she took on the daunting task of creating her own endless runner on Arduino, which is very complicated, and trying to figure out everything, including the wiring and the code itself, was very hard. And she was able to pull it all together in her 6 weeks here and come up with a really, really cool game and her own awesome mods. So without further ado, Rashonda, would you like to present your project?
Hello, my name is Rashonda, and I'm making the Arduino run-on game. Wait, give me a second. And it was a very interesting project because I really like play video games. I wondered like what the controls were for it. The few modifications that I made were the buzzer and adding a few buttons. So every time you die, you will hear this sound.
Rashonda, are you able to talk a little closer to the microphone? I don't think we can hear you.
Yeah.
We might be having technical issues and need to move to the next one.
Okay.
All right, awesome. So Rashonda, we'll come back to you in a little bit. Shifa, do you want to continue on with your next student?
Yeah, sure. So the next student is Advait. Yeah. So his project is about image recognition, and I would like to introduce you like about him. So he's very enthusiastic person, and he's open to learning and exploring new things. And I like his never give up attitude when it comes on like researching about the data sets or debugging the errors, and even when even being behind me and Jason about each and every buggy faces. And yeah, so Advait, would you like to share your project?
Yeah, hi, my name is Advait. I'm going to be a senior next year at Archbishop May High School in San Jose, California. My project was using Raspberry Pi for image classification on a specific data set. And the data set that I decided to use was a materials data set that was created by MIT. So it categorizes the images into classes like water, foliage, fabric, paper, stone, those basic kinds of images. So I need to share my screen here. So first I tried running it on the Raspberry Pi, but it ran out of storage very quickly. So I decided to continue doing the project on my Mac and eventually using the TensorFlow Lite program to transfer the operation onto my Raspberry Pi. So to start off, I'm importing a bunch of modules and libraries that allow me to use neural networks embedded inside this network. And then as you can see on the left side, there's a Google Drive files here with the data set that I'm using. So in this specific image branch, it has all the directories of the folders. So basically with this code, I'm basically following a model of the MobileNet V2, which has the highest accuracy. It took a while for me to find this model because all the previous ones that I used had very low accuracy values of about 9–10%, something which isn't expected for this type of project. So continuing with that, I created both a test drive and test directory and a validation train and validation where it allows me to train it using the embedded neural network within the MobileNet V2. And from there, here it shows like the basic images that it's trying to interpret, like plastic, leather, wood. It shows like some 9 images. And then it also tunes the data set, making sure there's not any errors while doing the pre-training process, pre-processing and that kind of augmentation as well. And then here it shows the different augmentation basically increases the accuracy that you're getting when you're training the model. And here it's showing the various types of images, alterations, and changing, like rotating and performing other operations on it. So this is basically the layer that I'm using. It's a convoluted neural network, and there's a lot of layers. And although it seems that it's it can seem like a simple process in terms of input and output, there are a lot of dense layers that come into play when you're processing an image. So I tried to make my own models, use other neural networks, but obviously the accuracy values are really low. So going off from this, I had to compile the model, and I used a base learning rate of 0.01, which allowed me to train it as careful as possible, making sure that all the details are taken care of. So basically, here where I'm training the model, I'm using 20 epochs where it's basically going through each images like 20 times, and it's producing 20 different accuracy values. And so here, as you can see, it starts off slow at 10%, then it goes to 22, 25, eventually building up to 60%. This is actually the maximum that I could get to. I tried a lot to change a lot of values in there, like the dense layers in the neural network, but this was the maximum I could get to. And when I ran this cell of code here, it actually plots the training and validation accuracy. So as the number of epochs was increasing, the accuracy was also increasing. And then here, it's basically showing some images of some categorized as fabric, but as you can see, only 3 or 4 of these images actually fall under the category of fabric. And my next step from here is trying to implement this data set for other objects as well, since like my original idea was to use something to do with chemical compounds, but that was too complex to complete in a matter of 3 weeks. For the rest of the summer, I'm planning on using this neural network and making my own data set consisting of chemical compounds and for image classification on that end. So some of the lessons that I learned during this project was that neural networks are very complex, even though it may not seem like that. And I learned from the engineering side, I learned that software engineering is very important when it comes to a lot of operations that we witness in our jobs. So electrical engineering and software engineering are very useful tools in the modern world, and I'm interested in pursuing these in the future. Thank you.
Thanks, Advait. So does anybody has questions for Advait?
Yes, a great job, Advit. I have two questions. First of all, how large is your training data set?
So my training
large-
data set has, so there are 10 classes, and then each class has 100 images, so a total of 1,000 images.
1K. And how long does it take you to run the training period?
Well, this went by pretty fast, so I would say all of this took about 5 minutes for me. Obviously, if you increase the number of epics, the time is going to increase. So, yeah.
Thank you. Thanks. Those were the great questions. Yeah.
Awesome.
So,
That was a really cool project. Definitely cool to see some of that machine learning stuff, especially as a more of a mechanical side of Bluestamp. So up next, we have one of my last of the 6-week students, Eric. And Eric had a really cool project where he was able to make a solar panel, and I'll have him explain a little bit more why that's so cool. But before he goes, just wanted to share a quick story about Eric. Here at Bluestamp, in order to like give the students a little bit of a break, we usually run some sort of games in our main room. And one of the first games we ran is this game called Scribble. It's kind of like Pictionary. And the first time we played, there was like a top 3, and one of the heads, Gavri, usually wins. But this random kid named Potato was beating out Gavri all the time. And Gavri was so frustrated, he didn't know why he was losing. And for the longest time, he was trying to figure out who this Potato Kid is. And then we finally get back, and Eric really sneakily says, "Hey, Jesse, by the way, I'm Potato." So from that point on, he kept up that little bit of always making himself Potato or having me be Potato to throw Gavri off and just confusing him. So that was a lot of fun and a nice like introduction to Eric's goofier side, because we get to see all the technical and smart side normally. So it's nice to see the other sides of the students too. So after that, Eric, would you like to share how your project went?
Yeah, sure. So I'm Eric, as Jesse said. I am a rising sophomore at Lynbrook High School, class of 2024, and I chose the solar panel sun tracker and phone charger. Okay, so basically this is my project, and hold on. Okay, so it's really early in the morning, and here's my project. I left it out for a while, and as you can see, it's tilting towards the sun. And basically has 2 wires connecting on each side, and those are connected to photoresistors, which basically tell you how bright it is in terms of light. And I coded basically for the servo to rotate in one direction, the certain direction where there was more light. And that's my servo in there, and it basically just rotates. And that was basically phase 1 of my project. And phase 2 was actually doing the charging part, which was connecting my solar panel to like my my lithium ion battery and my power boost, which basically had the volts of the solar panel converted to 5 volts, so it could probably properly charge the portable charger. And yeah, and as you can see after this, I plugged it into a phone and it actually charged, which was pretty cool. So yeah, that's basically my project. And one of the mods that I did, which I really couldn't get to because of some Amazon setbacks, were basically getting a car to run with the LDRs on each side, and basically having the same tilt algorithm kind of, but instead of tilting, it would move in the direction of having more light. So one of the challenges I had was patience, because I had to wait for my project materials for a really long time. and that was really hard, but ultimately I got them, so it doesn't really matter. But one of the other ones, I don't really have a lot of challenges for this one. I think it was relatively okay. But one of the main issues I had were with the jumper cables, because my motor skills aren't the best and I kept unplugging random cables when I wasn't supposed to. Yeah, so one of the takeaways I had is that soldering isn't that scary. I saw 350 degrees Celsius first time I did soldering and I got scared. So after I did it, I felt more comfortable with it and it was fine. And I think I really took a lesson, which is just because it seems scary doesn't mean it is, which I think probably will help me in the future. And I enjoyed Blue Stamp engineering a lot and engineering in general because I thought it was a really good balance between the actual coding and building. So yeah, it's definitely something for me to look into in the future.
Awesome job, Eric. Really like to see how your project turned out. It was really cool. Does anyone have any questions for Eric?
I have a question if no one has.
Yeah, Shifa, would you like to ask?
Yeah, sure.
Yeah. So Eric, what was the most interesting part for you? Like, was it hardware or software?
I think it was the hardware, like
Mhm.
for the solar panel.
Mhm.
At the back, there's a wire with a head connector, and it didn't fit into anything. It didn't fit into the power boost or anything. So Jesse shipped me a couple of heads that would fit into the power boost. And it was really interesting because that was the first time I cut wires and actually stripped like the outside of it off. And actually I had to like use like screwdrivers, soldering irons, and like wire cutters. It was like really cool because I had to use like a whole assortment of tools to basically get that one thing to work.
Awesome. That's great.
Great job, Eric. All right, Shifa, do you want to continue us off?
Yeah, sure. Let's see. So it's Brandon. You're up next. So Brandon's project is about um, the case that he worked on, and it is using the fingerprint sensors and an Arduino. And I would like to tell more about him. Like he has, apart from his technical skills, he's extremely good at managing the timeline of his project, because he managed to finish each part of his project in a very timely fashion and without stressing out. So, and it's very important in engineering field that you have your project planned beforehand, you jump on to doing things. Yeah. And Brandon, would you like to go ahead?
Yeah, so I'm Brandon. I go to Mission San Jose High School. I'm going to be a senior next year. Yeah, and so my project was a fingerprint ID safe. It's a box that can only open if you have a correct fingerprint, essentially, or if you have a passcode as an override. And I chose this project because it was it seemed interesting to me. I never really got a chance to combine hardware and software. Fingerprint technology was pretty interesting and all that. Yeah, so I didn't get to like completely finish up everything that I wanted to get done all in these 3 weeks, but I definitely have future plans for the next session that I'm going to be attending. So I'm going to show a demo of my. All right. Yeah, so this is my safe. It's also here. But yeah, so this is the inside. The thing I'm holding right now is the fingerprint sensor. And as you can see, if I push my finger on it, the servo will turn slightly because that's the correct finger I'm using. This is supposed to be mounted to a locking mechanism, but that's one of the things that I didn't get to finish. just because I had basically no idea on how I was going to get the bracket to stay on the servo. Anyways, as you can see, if I hit it again, the servo will turn back. And if I enter my passcode, which is 123A456, and then I hit pound, which is enter, you can see the servo turns again. If I enter it again, it'll essentially close back on. Yeah. And the way I've programmed it is essentially whatever I input, whether it be a passcode or if it's fingerprint, the servo will turn to its other position. So it's got two positions at 90 degrees to lock and unlock it. Yeah, so you can say unlock the safe with your fingerprint and then lock it again with the passcode. The code handles all of those. But yeah, that's basically my project so far. As for modifications, there's definitely still a lot that I have to get done. And yeah, it's definitely going to happen next session. So I guess the next demo night. Challenges though, the keypad was extremely difficult. Well, not extremely difficult, but it was quite difficult to set up just because all the code had issues with it. So yeah, the passcode sample code that I had was it was designed so that you input a password of a certain length, and then it would just run it through, see if it matched, and then trigger something else. But the way I wanted it to do, it was you have a passcode that can be of any length, and all you have to do is hit a single button, and it'll essentially enter the password for you. So I had to modify the code a lot, and that resulted in a ton of bugs. But I eventually got everything worked out, and I got the passcode running. Lessons learned. I absolutely enjoyed combining the fingerprint sensor, the keypad, and the servo all together so that the whole thing worked, with itself. And I learned about the importance of troubleshooting and how to effectively troubleshoot. There were a ton of issues that got brought up, such as incompatible like pointers and strings. I had to modify a lot of that in the code. But yeah, I'm glad that I got the chance to work everything out. So any questions?
Okay. Wanna go? Okay. Dave.
Yeah, I want to know if you had more time and you could integrate any other system. I know you talked about modifications for next session, but I'd be interested in like if you had instead of 3 weeks, 9 weeks or 12 weeks, what would you implement?
Definitely if I had more time, I guess I'm thinking of a false bottom for the safe so that I can hide all the messy wiring and stuff. I need to mount all of my, password input methods on the side of the safe. I need I need a switch to basically turn everything off and on because unplugging the cord isn't, preferable. I'm thinking maybe some speakers to play some, sound or whatever when the safe locks and unlocks so that it can kind of hide the noise of the servo, as well as a bunch of other stuff. And then, yeah, so I still have a few issues with servo twitching. I've tried lower power, as I think Hadley has done before me, but it's still like twitching slightly. So I do want to get that worked out.
That's ambitious. I like all of these ideas. Nice work.
Yeah,
Thanks,
that's definitely
Brandon.
a lot of cool stuff that you got packed into that small box. Definitely very impressive, and I'd love to see what you come up with future modifications. All right, so next up we have Ayush, and Ayush is an awesome student. One of the best things that I got to see from him is whenever we have these breaks that I mentioned before, his one goal for any of those is just to beat me, which is a pretty achievable goal considering I'm not very good at half of these games. But it did show me that he had that like determination and grit that he would need for his project, because his project is one of the tougher ones that we have here at BlueStep. I don't want to spoil too much, but he was able to get a lot done, and even come up with some really, really cool modifications that like he's on the verge of completing, just a little bit time constrained. So Ayush, would you like to show what you were able to accomplish this summer?
Yeah, okay. Hi, my name is Ayush Taluri. I'm a current rising sophomore at Lynbrook High School, and I named my project as a ball tracking robot with a claw. So, the explanation of my base project. So, basically, my base project was a robot that uses a computer vision to track a ball, and I chose this project as I was basically highly interested in robotics, and this project basically encapsulated both the hardware and software aspects of robotics and also had like my own fun twists in it. And the main project consisted of a Raspberry Pi controlled robot, and it implemented image detection using OpenCV and a camera module, and it also used an ultrasonic sensor to measure the distance. And here is a video of my robot working, if I can get it up. There we go. So it's currently playing. So it first moves a bit, and once a ball comes in frame, you'll see that it starts moving a bit in slower portions. Move a bit slower. It's using a camera to detect whether the ball is in the center or not. And once it's centered, it'll start moving forward. And if it ever goes off center, like it does right about now, it'll recenter itself to the ball. And yeah, I know it's moving slowly. I had to use precision measurements because I was going to add a claw on the top, which needed to make sure that it was completely centered so that it could grab the ball. And I will fast forward through this. You can see eventually it gets to the ball and it'll stop and stay there for the rest of the video. And yeah, so I'll stop sharing. As I did mention before, I was planning to have a claw, and here's a prototype image of the claw that I was gonna put on my robot. I did end up putting it. I just had some issues with some code, and my goal for this was to have the claw first move down, then open up the claw, then close the claw, grab the ball, and move back up. And then if I wanted to put it in a goal or something, the camera wouldn't be blocked anymore, and then it can detect a goal and move towards the goal. And so basically, although it's not completed, I do aim to complete it in the near future and like in the summer and maybe even summers later on. One of the biggest challenges I faced was definitely using OpenCV. I was completely new to the software and using it to track a ball, and also getting the contour of a ball and finding the center of the ball was very difficult. But at the end, after I figured it out, I felt highly accomplished and proud of myself. So pat myself on the back there. But I will say another challenge I faced and currently still am facing is with the claw. Although it's wired up correctly and everything, the servos do experience a lot of twitching, and so it's very hard to get it to move down. So that was one challenge that I'm still facing and would like to overcome soon. And I'd say my favorite aspect of the project was definitely learning about the Raspberry Pi and learning all the different components that can be associated with the Raspberry Pi. In this case, like servos, a motor driver, ultrasonic sensor, and also a camera module that is, you can't see it, it's hidden under there, but there's a red beeping light in the video. And I guess overall, Bluestamp definitely gave me the opportunity to experience the engineering process, and I would say like I definitely fell in love with it. I truly enjoyed it. Um, I enjoyed building it using my own out-of-the-box thinking to sort of get solutions to problems. If you notice in the image, there's actually tape on my wheels, and that's because it was getting too much traction on my sticky laminate flooring, and so I needed to put some tape on it so that it wouldn't get too much traction and could move a bit better. And I guess I truly enjoyed it, and seeing it finally come together was like an amazing feeling. And overall, I continue to improve my project and definitely continue in the field of engineering. Any questions?
Yeah, I have a question for you. So I noticed you used a foam ball to track your as your like object to detect, but you're also using an ultrasonic sensor, which for those of you that don't know is emits sound waves to detect how far something is. but also foam like messes up sound because it's commonly used for soundproofing. So how do you kind of get around that issue of using a sound detection system and also a sound cancellation system in a foam ball?
So I ended up coming up with a pretty simple solution. So what ended up happening was every single time it got near the foam ball, it would rate out crazy measurements over like 400, sometimes 1,200 cm because the sound kept on getting trapped in the ball and wouldn't come back fast enough. And so what I ended up doing was just putting a limit saying that if it got greater than 100 cm, because it has a static measurement of around 9 or 10 cm, because it just goes to the ground and comes back. If it goes greater than that, it'll stop, and that means that the ball is there because there's not another object that can go that close to the robot. And that's how I figured out that for sure there'd be a ball there.
Awesome solution and awesome project. I really loved how it came out, and I can't wait to see if you can get that claw mechanism to work with it. Yeah, it was really cool to see you kind of put everything together.
Yeah, I like the setup. I mean, the way you set up everything, all the components, and you manage the space on it, because it's very difficult to put all those in that such a small area. And good job.
Yeah, thank you.
Definitely. All right, Shifa, you want to kick off your next student?
Yeah. So the next student is Zijin, and her project is smile recognition system using Raspberry Pi. And she selected this project because she loves coding, and I even loved her first milestone because she didn't receive the kit and everything on time. So she just practiced her Python programming skills, and she made a cool tic-tac-toe in that. And I would like to give the opportunity to Zijin. Yeah.
My name is Zijin. I am a rising senior at American Fork High School. So for my project, I created a smile recognition using a database with 400 images of like smiling and unsmiling faces. Is unsmiling a word? Yeah, not smiling faces. And well, because like my stuff arrived like 1 week late, so I was unable to finish the project, but I have like most of the code here. So from line 2 to line 4, so the code here just uploads the faces data set with like open and closed eyes and stuff. And then like from line 5, it just like, and line 6, as shown here, it just plots like some faces from the data set. And then from line 7 and on, the code just produced the smile training data to store the outcome of the user classification. And which like just displays this huge face here. And then the graph is here to like visualize the data. And then it'll display like a series of smiling faces and like not smiling faces to just like classify the stuff. And then here it is just detecting like the output and seeing if like the face is smiling or not. And from here on, I am using OpenCV to capture the face image, but I still have like some to finish. So for this project, some of the challenges I encountered was like basically just the coding part mainly, because like the program, the example code, it has so many bugs. Like I just have to fix the bugs. It's a little bit challenging since like it's hard to find like the exact solution and have to play around with like multiple ones. And some of the lessons learned during this project, well, I just learned that Google is my friend. Thank you, Google. As for my project, I just plan to continue fixing the bugs in the code and eventually just like transform the exacted image to detect whether like the person is smiling or not. So like just the facial expression. And then there are like a few functions I have to write and it will work, hopefully. Any questions?
Any questions for Zijin? So I have a question, Zijin. So like, do you plan on transferring your train model on Raspberry Pi? So
yes.
What are your, can you please tell us about that? How you're gonna do the detect the image, like smiling or not?
I plan to do the live detection through the camera, which is connected to my Raspberry Pi. So currently I have like a camera connected to the Raspberry Pi with also an LCD screen for like controlling the Raspberry Pis graphically. And the Raspberry Pi is also connected to a power source and a mouse and keyboard. So I was thinking I could maybe find a way to copy paste the code.
Okay, great.
Great job. I always love these machine learning projects. They're so cool. They require so much work to do, and it's always amazing to see what the students are able to get done. Okay, next up we have one of the students that I've had the most fun with in my class. He's definitely the youngest student I've ever had, and he's also one of the funniest. He loves to occasionally, just in the middle of when we're working, talking technical engineering for like a nice hour and a half, and he'll just randomly throw in, so hey Jesse, what's your hobbies like? Or hey Jesse, what movie did you watch yet the other day? So you never know what you're gonna get with him. He always gives some fun takes on what he likes, and he wants to know your fun takes too. So it's always nice to have a nice break between all the technical engineering that usually goes on in our classrooms. With that, he also has some crazy ideas that he was able to think of. And initially when I saw them, I wasn't sure if he was going to be able to accomplish them. But as we got closer and closer, he got so far into those ideas, and I'll have him introduce them to you himself. So Shash, do you want to come up and introduce your project?
Yeah, sure. So hi, my name is Sashwat, and I'm a rising 7th grader at Miller Middle School, and I'm working on a gesture-controlled robot with the claw. So basically the base project was obviously just the gesture-controlled robot, and it uses an accelerometer and ESPs to move the robot. For example, if you were to tilt your hand forward, the robot will move forward too. Here is a demo of the project. Basically how the robot works is that this is just basically the circuit wiring. And basically how the robot works is that on the glove that I'm showing right now, there's an accelerometer, as you can see this blue part over here. And basically the accelerometer reads values and it sends the values to the ESP, as you can see right here on the glove. And that ESP is connected to the ESP on the robot. And depending on the value that the ESP on the robot receives, it'll move forward, backward, left, or right. And I'm just demonstrating the different ways it can move. I'll stop sharing. So I chose this project because I thought it was cool how it simulated telekinetic powers, and it also used components I've never used before. And I'm also very interested in robotics, so I was already drawn forth to it, and I just thought of it as a learning experience, and also just a very cool project that I was interested in. So I had multiple modifications I wanted to do, but through process of elimination, I ended up doing a claw modification, and it's right here. Basically, I was thinking of mounting a claw on top of the robot, and I have a whole other glove for my left hand. And based on my movements, the claw will like open, close, move down and up, and different kinds of movements for it. I wasn't able to get it finished, so I still have to work on it, and hopefully I can finish it in the near future. So a challenge that I faced for the hardware and the circuit board and stuff, it was mainly just I'm doing a tank drive, so I have to put 2 wires into one output. And that part was really hard. Like I couldn't just get it in, and the screws were not like tightening enough. And one of the screws even got stuck, but I ended up using a different kind of wire, and that already had a bit of traction or friction, so it just stayed in by itself. And the other challenge, the biggest challenge probably, was the trying to get the ESP to send accelerometer values. And that part was really hard because it just wouldn't send accelerometer values. And it would send different kinds of values, but the accelerometer values would just take so long to send. And finally, I found a code online to send a humidity sensor value, and I just adapted the code to send accelerometer values. My favorite aspect of the project, basically just the project as a whole and what it can do. And once I finish my claw, the claw would probably be my favorite aspect. So stuff I learned is that I learned how to use ESPs and accelerometers, and now I know a lot more about it, and I'm more comfortable with it. And also I learned more about the debugging process and how to debug different types of code and find a solution, and also pinpoint the problem. I hope to expand more on the projects and try and finish my other modifications I had in mind, including the claw. And I would definitely still pursue engineering because I really like the feeling of just seeing a project that you really have a passion for just come alive in front of you. And instead of getting a pre-made thing, I'm making it by myself. And it's just much more valuable than anything else you can get. So are there any questions?
Yeah, I had a quick question. So is there any chance you want to share what one of those other mods that you had in mind were that you weren't able to get done?
Yeah, the mod that I wanted to do the most was a mind control modification, and it uses like this really old toy from like 2010s that called Mindflex, and it basically just reads EEG waves from your head. And I'm not exactly sure how it works yet, but using there's also like an eye sensor that you can like connect to your glasses or something, and that just makes the robot move forward, backward, left, and right. And but the Mindflex headset wouldn't come in time, like and so I couldn't do that modification, unfortunately.
Yeah, it was still like a very awesome idea. It's something that I definitely haven't heard of before. So hopefully you can one day get that done yourself, but definitely like really creative to even come up with that. So very cool, and I'm very proud of everything you were able to get done so far. So good job. And I think Shifa, we have our last student. So you want to introduce?
Yeah. So last but not the least from my group. So his name is Oliver, and I would like to say he's a great researcher when it comes to researching out sensors, motors, and any coding issues you get. He'll just do it in he'll figure it out independently. And he didn't ask me a lot of questions because I know he was doing his work. So yeah, so he's a lot of independent guy. And yeah, Oliver, would you like to go ahead?
Sure. Thank you, Shifa. Okay. Hi, everyone. I'm Oliver, and I'm an incoming senior at Leland High School in San Jose. And actually, my project is a ball tracking robot. The name of it is a little bit deceiving, actually. It's not tracking like a circular object. What it really tracks is actually color. But even then, I was really drawn into this project because, wow, this is like computer vision, right? This is a machine that's able to actually see the real world. But even more than that, I actually really like this because it also combined with robotics hardware. So not only can this code somehow see the world, but also interact with it. So that was incredibly cool. In terms of any types of modifications, I didn't go with anything really grandiose, I guess, but I did want to make sure that I could control the robot car. I definitely didn't want it to be just sort of like running off on its own because it sees some sort of color far off in the distance, right? So I actually added a way to remotely start and stop the program. This took advantage of the keyboard that Bluestamp sent over. It's a wireless keyboard. So I was able to actually, with a little bit of tweaking, put in code that could actually remotely start, stop, and pause the program. So with that in mind, I guess it's time to actually, well, show what the project can do. So let's see. All right. So I actually use a red ornament here, and I'm starting with opening up a new terminal. And now you can see that the robot car actually moves on its own. And by dangling the red ornament near it, it's able to remember which direction the ornament is in and actually turn towards that direction and then, drive towards it. And then the next thing that I actually did was modifying this car so that, as you can see here, there are no external wires, right? Nothing with the Raspberry Pi is connected to a wall socket or anything like that. And here I've paused it and then restarted the code. And as you can see, it works just fine and it's able to track a ball in front of it. Yes, and then I also have a quit function, which stops the program entirely. Yes, so I think that this project, initially when I was working on it, it was basically Raspberry Pi code on a screen and like a set of wheels maybe on a chassis sitting on like a makeshift bench. And it didn't feel like very real, I guess. It seemed like a bunch of parts, honestly. But once I saw it actually start to like come together and run on the ground, I was like kind of in love with seeing how I was able to create something with code and it could actually move around in the real world. Clearly, though, there were definitely challenges. As Shifa actually already mentioned, there was definitely some code issues with, for example, some of the code is actually kind of outdated. So I had to figure out how to find replacements or otherwise work around it. As everyone here has actually already said, right? Google, Stack Overflow, they're awesome. And then another thing that I actually learned, or I was challenged by, is actually the wiring of the motors. So just to give an example, right? The motors here also use tank steering. So I had to figure out how to wire them correctly. And when I first started it, well, the forward command made the car go right, and the left command made the car go backwards, and it was just a mess. But I was actually able to use that code and record everything, and then use a little bit of logic to analyze and correct that wiring, which was actually a kind of fun experience. So overall, I learned some more specific things applicable to this project, such as OpenCV and how to solder wires, for example. But I also learned something much more applicable to everything, really. Engineering as a whole, and probably life, is that, well, planning is important, but it's also important to figure out what to do when plans go in an unexpected direction. Okay, thank you.
Wow,
And are
that
there any
was a great
questions?
That was a great presentation, Oliver. Good job. So I don't have any question, but I would like to just say, like, your car is just placed behind you, right? So will it detect your red shirt and move around?
Oh, well, you can see currently it's actually sitting on the bench right now.
Yeah.
My bench is like a makeshift stack of calculators, actually. But like, yeah, I set it on the floor actually because it turns out that this car really likes to like zoom across. So I'm gonna keep it on the bench for now.
Okay. Great.
Awesome job. And awesome job to everyone. I definitely like to take a second on behalf of me and Shifa to congratulate all the students for all the amazing hard work they've put in. Watching you guys progress through your projects has been super inspiring and super fulfilling to be your instructors for this entire process. We're all very, very proud of you guys and everything you were able to accomplish. So round of applause for your students. I'd also like to thank everyone who chose to send their students to Blue Stamp. It's an absolute pleasure to be able to be trusted with your students and to have them here for the summer. Getting to meet them and know them as people and engineers is truly awesome. And we're very, very happy you chose to have us be your instructors for the summer. So great job, everyone. Thank you so much for coming. And I hope you guys have a great rest of your evening.
Thanks, everybody. You can feel free to go. If you have questions, you can stay and hang out, but